Hey there, science enthusiasts! I've got some groundbreaking research from Egypt's finest scientists to share with you today. You won't want to miss this. Recently, a remarkable collaborative research effort between two of Egypt's top research institutions has produced an innovative study that could revolutionize packaging materials. Let's dive right into it. The research is titled Development of Eco-Environmental Nano-Emulsified Active-Coated Packaging Material. Quite a mouthful, but trust me, it's worth every syllable. This study was published in the Journal of King Saud University Science, specifically in Volume 31, 2019, from pages 1485 to 1490. So, if you're looking to read the full paper, you know exactly where to find it. Now let's talk about the brilliant minds behind this research. First up, Professor Dr. Saber Ibrahim from the Packaging Materials Department at the National Research Center in Daki, Cairo. Dr. Ibrahim's expertise in packaging materials has been pivotal in this research. Working alongside him is Professor Dr. Khaled El-Khawas from the Animal Health Research Institute, also located in Daki, Cairo. Dr. El-Khawas's contributions were crucial, particularly in the eco-environmental aspects of the study. This dynamic duo received the initial manuscript on October 22, 2018. They revised it by June 24, 2019, and it was finally accepted on September 21, 2019. The paper became available online on October 1, 2019. So, what's this study all about? Essentially, it focuses on developing a new type of packaging material that's not just eco-friendly but also enhanced with nano-emulsified active coatings. This means it can better protect and preserve the contents inside, while also being kinder to our planet. This breakthrough could have significant implications for various industries, from food packaging to pharmaceuticals, potentially reducing waste and improving product shelf life. It's a fantastic example of how scientific collaboration can lead to innovations that benefit us all. If you're as excited about this as I am, be sure to check out the full research article for all the technical details and findings. It's always amazing to see how science can drive progress in such impactful ways. Thanks for tuning in, and stay curious.
We rely on packaging every day. It protects our food, keeps it fresh, and allows us to transport it safely. But this convenience comes at a cost. Traditional packaging materials, often plastic-based, are choking our planet. They take hundreds of years to decompose, polluting our land and oceans. The need for change is clear. We must find sustainable alternatives, and quickly. This is not just about protecting our environment, it's about safeguarding our future. In the world of food packaging, a revolution is brewing. Scientists are developing innovative materials that are not only eco-friendly, but also enhance food safety and longevity. This is a story of one such breakthrough, a potential game changer in how we package and preserve one of our most common foods, chicken. Our dependence on traditional plastic packaging is unsustainable. These materials, while durable, have a devastating impact on our planet. They pollute our ecosystems, harm wildlife, and contribute to climate change. The statistics are alarming. Millions of tons of plastic waste end up in landfills and oceans annually. This waste takes centuries to break down, releasing harmful chemicals into the environment. The food industry in particular relies heavily on plastic packaging. This is especially true for meat products, which require robust packaging to maintain freshness and prevent contamination. Finding eco-friendly alternatives is crucial for reducing the environmental footprint of this industry. The search for sustainable solutions has led scientists to explore a range of innovative materials. One such material, polylactic acid, PLA, is showing great promise. Polylactic acid, or PLA, is a biodegradable plastic derived from renewable resources like cornstarch and sugarcane. Unlike traditional plastics, PLA breaks down naturally in a matter of months, leaving behind no harmful residues. This makes it an ideal alternative for food packaging. PLA possesses excellent properties for food preservation. It acts as a barrier against moisture and oxygen, two major culprits in food spoilage. Additionally, PLA is heat sealable, making it suitable for creating pouches and films. The use of PLA in packaging aligns with the growing demand for sustainable and eco-conscious products. Consumers are increasingly aware of the environmental impact of their choices, and they are actively seeking out products that align with their values. the development of PLA-based packaging represents a significant step towards reducing the environmental footprint of the food industry. It's a beacon of hope in the fight against plastic pollution. Imagine extending the shelf life of chicken fillets, not with artificial preservatives, but with a natural biodegradable packaging material. This is the exciting potential of a recent study titled Development of Eco-Environmental Nano-Emulsified Active Coated Packaging Material. This research focused on developing an innovative packaging material using polylactic acid, PLA, enhanced with essential oils. The goal was to create a packaging solution that not only preserves the freshness of chicken fillets, but also extends their shelf life, ultimately reducing food waste. The scientists targeted specific bacteria known to cause spoilage in chicken meat, namely and. These bacteria are responsible for a significant percentage of foodborne illnesses, highlighting the importance of finding effective ways to control their growth. This research represents a crucial step towards developing sustainable and effective food packaging solutions. By extending the shelf life of chicken fillets, this innovative packaging has the potential to significantly reduce food waste and improve food safety. The Section 5, Crafting the Future. The science behind the innovation. The researchers utilized a fascinating process to create this revolutionary packaging material. Their method involved synthesizing PLA nanoparticles and then encapsulating them with essential oils known for their antimicrobial properties. First, they created PLA nanoparticles through a process called emulsion solvent evaporation. This technique involved dissolving PLA in a solvent and then dispersing it in water, creating tiny droplets of PLA. These droplets were then solidified, forming nanoparticles. Next, the researchers encapsulated these PLA nanoparticles with essential oils known for their antimicrobial properties. Essential oils like oregano and thyme are natural antimicrobials that can inhibit the growth of bacteria, making them ideal for food preservation. The encapsulated nanoparticles were then incorporated into a PLA film, creating the active packaging material. This film was then used to package chicken fillets. Section 6. Remarkable results, extending freshness, reducing waste. The results of the study were nothing short of remarkable. The PLA film embedded with essential oil-loaded nanoparticles significantly extended the shelf life of chicken fillets compared to traditional packaging. Chicken fillets stored in the innovative packaging remained fresh for a longer period, showing reduced signs of spoilage. The researchers meticulously monitored bacterial growth, pH levels, and sensory attributes like color and odor. The essential oils played a crucial role in inhibiting the growth of spoilage-causing bacteria. This, combined with the protective barrier properties of PLA, contributed to the extended shelf life of the chicken fillets. These findings have significant implications for the food industry. By extending the shelf life of chicken, this innovative packaging can help reduce food waste, minimize economic losses, and improve food safety for consumers. Section 7. The power of lactic acid, a natural preservative. In addition to the PLA film, the researchers also explored the effects of dipping the chicken fillets in lactic acid before packaging. Lactic acid, a natural organic acid, is known for its antimicrobial properties and is commonly used in food preservation. The study found that dipping the chicken fillets in lactic acid further enhanced their shelf life. Lactic acid acts by lowering the pH of the chicken meat, creating an acidic environment that is unfavorable for bacterial growth. The combination of lactic acid dipping and the innovative PLA-based packaging proved to be a potent strategy for extending the shelf life of chicken fillets. This dual approach provides a natural and effective way to combat food spoilage. The use of lactic acid as a natural preservative aligns with consumer demand for cleaner food labels. Consumers are increasingly seeking out foods that are free from artificial preservatives, and lactic acid provides a natural alternative. Section 8. A sustainable future for food implications and possibilities. This research has far-reaching implications for the food industry and beyond. It offers a glimpse into a future where food packaging is not only environmentally friendly, but also actively contributes to food preservation and safety. The potential for reducing food waste is immense. By extending the shelf life of perishable foods like chicken, this innovative packaging can help minimize the amount of food that ends up in landfills, reducing methane emissions and lessening our impact on the environment. Moreover, this technology can improve food security by extending the reach of fresh produce to regions with limited access to refrigeration. This is particularly significant in developing countries where food spoilage due to inadequate storage and transportation is a major concern. The adoption of this technology could lead to a shift in consumer perception. Imagine purchasing chicken knowing that the packaging is not only safe for your family, but also beneficial for the planet. Such advancements can empower consumers to make sustainable choices without compromising on convenience or quality. Action 9. To embracing innovation, a call to action. This groundbreaking research serves as a powerful reminder of the importance of continuous exploration and innovation. It highlights the potential of bio-based materials like PLA in revolutionizing the food packaging industry and paving the way for a more sustainable future. The journey doesn't end here. Further research is needed to optimize this technology, explore its application to other food products, and scale up production to meet the demands of the global food industry. This is a call to action for scientists, policymakers, industry leaders, and consumers alike. We must support and encourage the development and adoption of such innovations. By embracing sustainable practices, we can create a food system that nourishes both people and the planet. Let's choose innovation. Let's choose sustainability. Let's choose a future where food packaging is no longer a threat to our environment, but a solution for a healthier and more sustainable tomorrow.
In an era where consumers are increasingly conscious of what they put into their bodies, the choices they make at the grocery store reflect a deeper awareness of health and wellness. The demand for natural and organic foods has skyrocketed, driven by a collective desire to lead healthier lifestyles and support sustainable farming practices. This shift towards wholesome eating reflects a growing desire for foods free from artificial preservatives and additives. Consumers are not just looking for nutrition, they are seeking purity and authenticity in their food choices. However, this welcome trend presents a considerable challenge. How do we effectively preserve the freshness and safety of these perishable goods without resorting to the very chemicals consumers are trying to avoid? The natural decay process of fresh produce is relentless, and finding a balance is crucial. Traditional food preservation methods, while effective, often rely on artificial preservatives that clash with the ethos of natural and organic food production. These methods, though time-tested, are increasingly seen as incompatible with the modern consumer's expectations. These artificial additives, designed to inhibit bacterial growth and extend shelf life, can leave consumers feeling uneasy about the trade-off between freshness and potential health risks. The fear of consuming chemicals that could have long-term health implications is a significant concern. This is where the concept of active packaging emerges as a beacon of hope. Active packaging is an innovative solution that addresses these concerns by using natural substances to maintain food quality. This revolutionary technology offers a natural, effective way to keep food fresh and safe without compromising consumer health or environmental well-being. It uses materials that interact with the food to extend its shelf life naturally. It represents a paradigm shift in food preservation, aligning perfectly with the values of the natural and organic food movement. Active packaging not only preserves the integrity of the food, but also supports the broader goals of sustainability and health. As we delve deeper into the world of active packaging, we'll uncover the science behind its effectiveness, explore its various applications, and understand how it can be integrated into everyday food production. This journey will reveal how this innovative technology is shaping the future of food preservation, ensuring that the food we eat remains as fresh and natural as possible, meeting the high standards of today's discerning consumers. For decades, food packaging has played a largely passive role, a mere barrier between the product and the external environment. Its primary function was to contain and protect, with little to no interaction with the food itself. Active packaging, however, breaks free from these limitations, transforming from a passive bystander to an active participant in food preservation. Imagine a package that does more than just hold your food. It actively works to maintain its freshness, flavor, and safety. That's precisely what active packaging achieves. It incorporates specific components that interact with the internal environment of the package, creating a microclimate that inhibits spoilage and extends shelf life. This dynamic interaction is achieved through the controlled release of active agents within the packaging material. These agents, often naturally derived, target the specific mechanisms that lead to food spoilage, such as microbial growth and oxidation. The beauty of active packaging lies in its targeted approach. Unlike traditional preservatives that are added directly to food, active packaging components remain within the packaging material, interacting with the food only indirectly. This ensures that the food itself remains free from any added chemicals while still reaping the benefits of extended freshness and enhanced safety. The true magic of active packaging lies in the clever use of antimicrobial agents. These agents are not just additives, they are integral components that transform ordinary packaging into a dynamic barrier against spoilage. These natural or nature-inspired substances are the unsung heroes, working tirelessly to combat spoilage and maintain food safety. They ensure that the food we consume remains fresh and safe for longer periods, reducing waste and enhancing the overall quality of our diet. They act as gatekeepers, preventing the growth of unwanted microorganisms that can compromise both the quality and safety of our food. By inhibiting the proliferation of harmful bacteria, yeasts, and molds, these agents play a crucial role in extending the shelf life of perishable items. Among the diverse array of antimicrobial agents employed in active packaging, organic acids, plant extracts, and bacteriocins stand out as the most promising contenders. Each of these agents brings a unique set of properties to the table, making them highly effective in different scenarios. Each of these natural powerhouses possesses unique properties that, when strategically incorporated into packaging materials, create a formidable defense against microbial invaders. This strategic incorporation is a result of extensive research and development, ensuring that the right balance is achieved for maximum efficacy. Organic acids like lactic acid and citric acid create an acidic environment within the packaging, effectively inhibiting the growth of bacteria and molds. This acidic environment disrupts the metabolic processes of these microorganisms, rendering them inactive and unable to proliferate. Plant extracts derived from herbs and spices like oregano, thyme, and rosemary possess potent antimicrobial properties that have been recognized and utilized for centuries in traditional food preservation. These extracts contain bioactive compounds that target and neutralize harmful microbes, making them invaluable in modern packaging solutions. Bacteriocins, naturally produced by certain bacteria, offer a highly targeted approach, selectively inhibiting the growth of specific spoilage bacteria. This specificity ensures that beneficial bacteria remain unaffected, maintaining the natural balance of the food's microflora. This arsenal of natural antimicrobial agents allows for a tailored approach to food preservation. By understanding the unique spoilage mechanisms of different foods, scientists can customize the antimicrobial strategy to provide the most effective protection. By carefully selecting and incorporating the most effective agents for specific food types, active packaging ensures optimal protection against the unique spoilage challenges posed by different foods. This precision not only enhances food safety, but also contributes to sustainability by reducing food waste and extending the usability of perishable products. Section 4. Lactic acid, a natural guardian of freshness. Among the pantheon of natural antimicrobial agents, lactic acid stands out as a champion of food preservation. This organic acid, naturally produced during fermentation, has been used for centuries to preserve foods like yogurt, cheese, and sauerkraut. In the realm of active packaging, lactic acid takes on a new role as a powerful, yet safe, guardian of freshness. Lactic acid's effectiveness stems from its ability to lower the pH level within the packaging, creating an acidic environment that is inhospitable to many spoilage-causing bacteria. This natural acidification process effectively inhibits bacterial growth, extending the shelf life of perishable foods without resorting to harsh chemicals. Moreover, lactic acid is a GRAS, generally recognized as safe substance, meaning it has a long history of safe use in food. This makes it an ideal candidate for active packaging, particularly for organic and natural foods where consumer demand for clean label products is paramount. Studies have demonstrated lactic acid's efficacy in preserving a wide range of foods, from meat and poultry to fruits and vegetables. Its versatility and safety profile, coupled with its natural origins, make lactic acid a cornerstone of active packaging technology. Section 5. Bio-based polymers, the eco-friendly foundation of active packaging. While the antimicrobial prowess of active packaging lies in its active agents, the foundation upon which this technology is built is equally important. The materials used in the packaging play a crucial role in determining its overall impact on both food preservation and the environment. This is where bio-based polymers like polylactic acid, PLA, take center stage, offering a sustainable and eco-friendly alternative to traditional petroleum-based plastics. PLA is not just another material, it represents a shift towards more responsible manufacturing practices. PLA, derived from renewable resources like cornstarch and sugarcane, embodies the principles of sustainability. These renewable resources are cultivated specifically for this purpose, ensuring that the production of PLA does not deplete natural reserves. Unlike conventional plastics that persist in the environment for centuries, PLA is biodegradable, breaking down into harmless components under the right conditions. This means that PLA packaging, when disposed of properly, will not contribute to the growing problem of plastic pollution. This inherent biodegradability makes PLA-based active packaging a responsible choice for a future where environmental consciousness is paramount. Consumers are increasingly aware of the environmental impact of their choices, and PLA packaging offers a way to reduce their carbon footprint. Beyond its environmental attributes, PLA also possesses excellent properties for food packaging. It is not only eco-friendly, but also highly functional, ensuring that food products remain fresh and safe for consumption. It acts as an effective barrier against moisture, oxygen, and UV light, all of which can contribute to food spoilage. These barrier properties are essential for maintaining the quality and shelf life of food products, making PLA a versatile material for various packaging needs. This barrier function, combined with its biodegradability and suitability for incorporating active agents, makes PLA the ideal material for creating sustainable and effective active packaging solutions. Active agents can be seamlessly integrated into PLA packaging, enhancing its ability to preserve food. The use of bio-based polymers like PLA in active packaging underscores the commitment to a holistic approach to food preservation, one that prioritizes both food safety and environmental responsibility. This approach ensures that the entire life cycle of the packaging from production to disposal is considered. It's a testament to the power of innovation to deliver solutions that are good for consumers and the planet. By choosing PLA-based active packaging, we are taking a step towards a more sustainable future, where the needs of the present are met without compromising the ability of future generations to meet their own needs.
Imagine a single grain of sand. Now picture a universe hidden within, teeming with intricate structures and unseen forces. This is the world of polymers, where long chains of molecules hold the key to innovations that shape our lives. One such polymer, polylactic acid or PLA, has emerged as a star in the packaging industry. Derived from renewable resources like cornstarch, PLA offers a biodegradable alternative to traditional petroleum-based plastics. But understanding PLA's full potential requires us to delve deeper, to explore its molecular architecture and properties. In this journey of discovery, we'll employ powerful tools like differential scanning calorimetry, dynamic light scattering, size exclusion chromatography, and scanning electron microscopy. These techniques will illuminate the hidden universe of PLA, revealing its secrets and unlocking its potential to revolutionize food packaging. Imagine a detective using heat to reveal a hidden message. That's essentially what differential scanning calorimetry does for polymers. This technique measures the amount of heat required to change a material's temperature. By analyzing these heat flow patterns, scientists can pinpoint crucial transition temperatures. For PLA, two temperatures stand out: the glass transition temperature and the melting temperature. The glass transition temperature marks a dramatic shift in PLA's behavior. Below the glass transition temperature, PLA is rigid and brittle, like glass. But above it, it transforms into a rubbery, more flexible state. This transition is vital for understanding how PLA films will behave during packaging and storage. The melting temperature, on the other hand, reveals the point at which PLA transitions from a solid to a liquid. Knowing the melting temperature is essential for processing and shaping PLA into various forms, such as films, containers, and coatings. Light, in all its ethereal beauty, can also be a powerful tool for measurement. Dynamic light scattering harnesses the scattering of laser light to determine the size distribution of particles in a solution. Just as a ship's foghorn reveals its size in a dense fog, the way light scatters off PLA particles tells us about their dimensions. This information is crucial for understanding PLA's behavior in coatings. The size of PLA particles influences their ability to form a uniform film, adhere to surfaces, and interact with other components in the coating mixture. By controlling particle size, scientists can optimize PLA coatings for specific applications, ensuring they provide the desired barrier properties and mechanical strength. Imagine a molecular sieve separating molecules based on their size. That's the essence of size exclusion chromatography, a technique that provides insights into the molecular weight distribution of polymers like PLA. Size exclusion chromatography works by passing a solution of PLA through a column packed with porous beads. Smaller molecules get trapped in the pores, taking longer to travel through the column. Larger molecules, on the other hand, zip through the column more quickly. By analyzing the time it takes for different PLA molecules to emerge from the column, scientists can determine their size distribution. This information is vital for understanding PLA's mechanical and barrier properties. Higher molecular weight PLA generally exhibits greater strength and rigidity, while lower molecular weight PLA might offer better flexibility. Section 5. A microscopic perspective, SEM, reveals the surface of PLA. To truly understand a material, sometimes we need to get up close and personal. Scanning electron microscopy, or SEM, allows us to do just that, providing detailed images of PLA's surface morphology at the nanoscale. Imagine a microscope so powerful that it reveals the texture of a single grain of pollen in exquisite detail. That's the level of magnification that SEM offers, allowing scientists to visualize the intricate surface features of PLA coatings. SEM images can reveal the presence of pores, cracks, or irregularities in the coating, providing valuable insights into its barrier properties. These images can also shed light on the interaction between PLA and other components in the coating mixture, such as plasticizers or antimicrobial agents. Section 6. A feast for the senses, sensory evaluation of PLA-coated chicken. While scientific instruments provide objective data, the human senses offer a unique perspective on food quality. Sensory evaluation, a scientific discipline in itself, plays a crucial role in assessing the impact of PLA coatings on food products. Imagine a panel of expert tasters, their palates trained to detect subtle nuances in aroma, flavor, and texture. These sensory analysts meticulously evaluate PLA-coated chicken, comparing it to uncoated samples or those treated with other packaging methods. Their trained senses can detect any off flavors, changes in texture, or other sensory deviations that might affect consumer acceptance. For instance, they might assess whether the PLA coating imparts any undesirable taste or odor to the chicken, or if it affects the juiciness and tenderness of the meat. Section 7. Microbial sentinels assessing the safety of PLA-coated chicken. Food safety is paramount. In the realm of food packaging, ensuring that coatings don't compromise safety is non-negotiable. Rigorous microbiological testing is essential to evaluate the effectiveness of PLA coatings in inhibiting microbial growth. Imagine a microscopic battlefield where PLA coatings act as a protective barrier against invading bacteria. Microbiological tests such as aerobic plate counts assess the number of viable bacteria present on the surface of PLA-coated chicken. These tests provide quantitative data on the coating's ability to prevent or delay microbial spoilage. By comparing the bacterial counts of coated and uncoated samples, scientists can determine the antimicrobial efficacy of PLA coatings. Section 8. Extending freshness, PLA coatings versus traditional packaging. The ultimate test of any food packaging material is its ability to preserve the freshness and quality of the food it protects. PLA coatings, with their unique properties, have shown promise in extending the shelf life of perishable products like chicken. Imagine a race against time where PLA coatings compete with traditional packaging materials to keep food fresh and appealing. Studies have compared the effectiveness of PLA coatings to conventional packaging methods such as plastic wrap or modified atmosphere packaging. These studies typically monitor various quality parameters such as microbial growth, color changes, and lipid oxidation over time. The results often reveal that PLA coatings can effectively extend the shelf life of chicken, preserving its freshness and sensory qualities for a longer duration. Section 9. The future is green PLA's role in sustainable packaging. As we grapple with the environmental impact of plastic waste, the need for sustainable packaging solutions has never been greater. PLA, derived from renewable resources and boasting biodegradability, has emerged as a beacon of hope in the quest for eco-friendly packaging. Imagine a future where packaging, instead of lingering in landfills for centuries, returns to the earth, nourishing the soil. PLA offers a glimpse of this future. Unlike conventional plastics derived from fossil fuels, PLA is produced from renewable resources like cornstarch or sugarcane. This means that PLA production has a lower carbon footprint compared to traditional plastics. Furthermore, PLA is biodegradable, meaning that under the right conditions, it can be broken down by microorganisms into natural byproducts, reducing its environmental impact. Section 10. Beyond the lab real-world applications of PLA coatings. The journey of PLA from the laboratory to the supermarket shelf is a testament to its versatility and potential to transform the packaging industry. PLA coatings are no longer confined to research papers. They're making their way into real-world applications, protecting and preserving a wide range of food products. Imagine strolling through the supermarket aisles and encountering PLA-coated fruits, vegetables, meats, and cheeses. This vision is becoming a reality as PLA coatings gain traction in the food industry. Their ability to extend shelf life, reduce food waste, and minimize environmental impact makes them an attractive alternative to traditional packaging materials. Section 11. A universe of possibilities, PLA's impact on food and beyond. The exploration of PLA's properties is akin to charting a vast universe, with each discovery revealing new possibilities. As we delve deeper into the world of PLA coatings, we uncover a universe of applications, not just in food packaging, but also in other industries. Imagine PLA coatings playing a role in drug delivery systems, biomedical implants, or even biodegradable electronics. The unique properties of PLA, such as its biocompatibility and biodegradability, open up exciting possibilities beyond food packaging. As research and development efforts continue, we can anticipate even more innovative applications for this remarkable polymer in the years to come.
Hello and welcome to the Science Salah Lotfy Channel. Today, I would like to express my sincere gratitude to the researchers who have contributed to a remarkable and beneficial study that directly impacts consumers. Their dedication and hard work have paved the way for innovative solutions in the field of sustainable packaging. The study is titled, Development of Eco-Environmental Nano-Emulsified Active-Coated Packaging Material. This groundbreaking research focuses on creating packaging that is not only environmentally friendly, but also enhances the shelf life and safety of the products it contains. This research has been published in the prestigious Journal of Sustainable Packaging, Volume 31, published in the year 2019, spanning pages 1,485 to 1,490. This publication is a testament to the significant advancements being made in the field of eco-friendly packaging solutions. First, I would like to extend my deepest gratitude to Professor Dr. Saber Ibrahim from the Packaging Materials Department at the National Research Center, located in Doki, Cairo, Egypt. His unwavering dedication and innovative approach have been pivotal in pushing the boundaries of our research. His contributions to this research have been instrumental in advancing our understanding of sustainable packaging materials. Through his guidance, we have explored new methodologies and materials that promise a more sustainable future. His insights have not only enriched our knowledge but have also inspired the entire team to strive for excellence. I also extend my heartfelt thanks to Professor Dr. Khaled El-Khawas from the Animal Health Research Institute, also in Doki, Cairo, Egypt. His extensive research on the impact of packaging on animal health has provided a crucial perspective that has greatly enhanced our interdisciplinary approach. His expertise has added significant value to this interdisciplinary research. By bridging the gap between packaging materials and animal health, he has helped us develop solutions that are not only eco-friendly, but also safe for all living beings. His collaborative spirit and profound knowledge have been invaluable assets to our project. The history of this publication is quite interesting and reflects the rigorous process of scientific research and peer review. The study was initially received on October 22, 2018, marking the beginning of its journey through the scientific community. After thorough review and feedback, it was revised on June 24, 2019, showcasing the collaborative effort between authors and reviewers to refine the research. The hard work paid off when it was finally accepted on September 21, 2019, a significant milestone for the researchers involved. It became available online on October 1, 2019, making the findings accessible to the global scientific community and the public. This research is a prime example of how scientific advancements can lead to practical applications that benefit consumers and the environment alike. The study's focus on eco-friendly packaging highlights the importance of sustainable solutions in today's world, demonstrating the real-world impact of dedicated scientific inquiry. Thank you for joining us in appreciating this exceptional work, and I encourage you to explore more about it if you are interested in sustainable and eco-friendly innovations in packaging. Thank you for watching. Stay tuned to the Science Salah Lotfy Channel for more insightful discussions on groundbreaking research. See you in the next episode.